All right, welcome Year 11s to our next lesson on linear relations. We're going to look at linear modeling in this lesson. So we're going to be looking at some of the skills that we've been doing throughout this whole topic, and we're going to bring it together with some worded problems. We're going to see that those worded problems, there can be a range of different things that we might be asked to do, from say substituting to solving to graphing, so say sketching a graph. Lots of different things, all based around one question or one scenario. So I think I've got like four different problems to show you. We will see some similarities in these problems, and I'll try and, as best as I can, give you some pointers, I guess, with how to solve these sorts of scenarios that you're faced with. I'll acknowledge that yes, a lot of students find this aspect of the topic the hardest part, so applying the skills that we've been working on to questions like these ones. So I did want to acknowledge that, because I know that some of you will find this challenging, but like I said, I'm just going to try my best to try and give you as many tips as I can as we go through these ones. So we know that many situations can be modelled using a linear equation. This first one here is to do with the height of a plant, and how it's growing over time. So we're told in the question, in the description here, that when it was first measured, the height was 5 centimeters. So right at the beginning, before it started being measured here, or before we see the growth, we've got a 5 centimeter plant. So just going to write initially, because that's going to be an important point as we continue. And we're also told that plants grow at 6 centimeters per week. So one thing you want to look out for is this word per, because often that translates to the slope or the gradient of your graph. I'll say often, because sometimes if it's not per week, say it was per, I don't know, per day, but your axis said week, then you're not going to get the exact same gradient. But that's just a little clue. If you see that per, anything really that has a rate in it, so I might put a rate in brackets here, your rate is going to link to your gradient, because the gradient is a rate as well. So we've got here, letting h be the height and t be the time, we can write a rule that is going to join together these two variables, these two things. So the height initially was 5 centimeters. So that initially there, what you want to look for in a question is a starting value for whatever it is that you're looking at. And so here, the starting value is the initial height, and that will often be your y-intercept. So in our rule, remember our rules take the form y equals a plus bx. So what I've started off with is writing a, the y-intercept, so the initial value of our height, and then it's going to be growing by 6 centimeters for every week, so 6 times t. What that means is I've got this rule now that tells me if I want the height for any given week, I can substitute that week into here. It's going to multiply by how many weeks it's grown, so that'll multiply by 6, and then we'll add it to that original height. Now, the graph of that has been shown, and as you can see, it's already here, h equals 5 plus 6t. We see the y-intercept here at 5, and if we were to take the gradient of this line, we would find that it has a gradient of 6. So it's hard to see here, but basically as you'd move across 1 week, we've gone up 6 units, so it's gone up to 11. And then if we go across again, it would have gone up another 6, so it's gone up to 17. So the important features, the y-intercept is our starting height, or initial height, you can say as well. Now, they do call it an h-intercept. Now, that's only because we've got h on the vertical axis. So don't be afraid of using a different letter. So that's one way that you can describe it. Another way you can describe it, because it's the y-intercept or the h-intercept, it's that's always going to occur where your time is 0. So sometimes you can write it like this. It is the height when t equals 0. Because sometimes on the x-axis, you may not have time there, so it wouldn't make sense to say initially in that particular case. So it's good to recognize that you can write it like this, using your other variable and equating it to 0. Now the slope or the gradient is a rate. So you want to take any rate that's within that question. And we know that the rate here was the growth rate. So we can say it gives the growth rate of the plant, and just more specifically, that's per week. And we can say what it is, which is 6 centimetres per week. Oh, and I could say it up here as well, is the height when t equals 0 weeks, and add that information in. That was 5 centimetres. So growth rate or rate of growth, either of those would be acceptable. How much it grows every week, anything like that is spot on. So using these key ideas, we can investigate other relationships as well. So once you've got your intercept and your slope, you may be asked a load of different questions really. Like I could ask you, what's the height after 3 weeks? What's the height after 5 weeks? How long does it take for the height to get to 32 centimetres? All sorts of different stuff once you've got that equation. Moving on to the second example over the page, you'll see that this one is, we've got a graph given to us again. This one's to do with water being pumped into a partially full tank, so it's not starting from 0. So if you have a look here, we've got volume of the water that's in that tank, and we've got time along the bottom there. So our first question, how much water is in the tank at the start? So when time is 0, we can see that we've got our y-intercept happening here. So the key thing is to check your scale to make sure, okay, what is this value right here? We've got 0 and 400 either side of it. So right in between that would have to be 200. And then I just check that I've done that right. If it's going up in 200s, yes, that is consistent with what's happening on this scale. So I'll then answer the question and make sure I put the unit, because you'll see the unit is sitting here. It's in litres. It's also mentioned in the question up here as well. So there's 200 litres in there to begin with, because I can see, I can read that off the graph. How much water is in the tank after 10 minutes? Again, you can, if possible, you can go up to time is 10 and then read off the graph. Sometimes it is more difficult depending on the scale, but this one has been chosen specifically because we can see there's 1200 litres. Okay, the tank holds 2000 litres. How long does it take to fill? So this time we're looking at our volume being 2000, and we're having a look at what t value is at that coordinate, and we can see that it is at 18 minutes. So nice and easy to start off with. It's really just reading off your graph. The next part is asking us for the equation of this line. Now it says in terms of v and t, that's just your equivalent of y and x, of course, but you do have to use the letters that they are telling you to use. So you do have to use v and t. So there's a couple of ways that you can do this one. First of all, the y-intercept is probably the easiest part. So if we start off with that, we can see the y-intercept is 200. The second thing that you would need for the equation would be the slope. So one option is using this method. Now you would need to pick 2 points that are on your graph, so it doesn't matter which two you choose. I could just choose my first one here, which is 0, 200, and my second one even, which is 2, 400 if you wanted, and then do label this x1, y1, x2, y2, and I'd get my 400 minus 200, and that was over, and we had 2 minus 0. So 200 on 2, giving us 100. So you could do it that way, and then of course your final rule, just break that into, would be V equals, remember it's going to be in this form. So V equals 200 was A and 100 was B. So we've got 200 plus 100t. Now, your other option would have been just to use 2 points and use your calculator method. So I could have used, say, 0, 200, and any other point. So I'll just say the one that I had, which was 2, 400, and your CAS. Just make sure you're not writing it in terms of y and x, you're using v and t. Now that we've got our equation, just write it out again here, we can use it. We want the volume of water after 15 minutes, so that's your t value is 15. So what I can do is just substitute 15 into my rule. So that's going to give me 1500 plus 200, so that gives me 1700 litres. Now the final one, you'll notice it says, I'm going to put a box around it because it's a really important word that we want to look out for. At what rate is the water being pumped into the tank? So how many litres are pumped into it each minute? Now I mentioned earlier that this word rate, whenever you are asked for a rate, you want to look at your slope, also known as the gradient. Because if we were to look at our slope, if you consider how much per minute, that would mean that we're going to halfway along this little triangle. So we really want to know how much is it going up every single minute. So if this is a run of 1, how much has it risen at that point? Well, it's risen by 100. You wouldn't need to do this, because once you recognize that this slope here is actually telling us how much volume is increasing every minute, then you can go straight to writing this as your slope that you found earlier. It was 100 as the slope, as B, so that means that we're the rate that water's going in is 100 litres per minute. So it is as simple as just looking at your rise and run. The rise was 100 litres for every 1 minute. And that's what happens when you do this formula up here. It's just simplifying a little bit, because of course this can be written as 100 over 1. So moving on to our next one. This is our third one of 4. This one here, we've got a charge. So these are popular ones. This is a car rental company. And in this one, we've got $80 for the hire of a car. And then we've got a cost per kilometre. Again, that per is really important. As soon as I see that, I know I'm thinking that we're talking about the slope here. The other number here, it's got charges $80 for the car. So that is our initial charge. And so I'm thinking already y-intercept. Sometimes you can gather those two things just from the question, just from the description of the question. Now to start off with, it's asking us how much would it cost. I'm going to use C for cost. We're going 300 kilometres. So just without thinking about an equation at all, let's just think about what we've been told. It's going to cost $80, plus it's also going to cost you 22 cents. Now, if you're working with something in dollars and cents, straight away you want to convert to the same unit of currency. So I'll change both to dollars. And so we're going to go 22 cents for every kilometre. So that's here has to be multiplied by 300 if we're going to go 300 kilometres. Now, you can do that on your calculator if you like. We should get $146. Now, one of the reasons you might be asked to do that to start off with is because it's going to help you generate your equation. If you have a look at part B, I should say, determine the cost for the distance of X kilometres. So all I would have to do is consider what calculation did I just do, which was 80 plus 0.22 multiplied by the number of kilometres. Instead of doing 300, I'm going to use X as the number of kilometres. And as you can see, this is in that form, y equals a plus bx. So I've got my linear equation that I can now use to graph, which is what I'm going to have to do next. So it's telling me to graph the function, and it's asking me to do that, and it's got this notation here, showing the coordinates of the intercept and the endpoint. So basically it's saying we don't want to graph this for an infinite number of values because that's impossible. It's just telling us how many kilometers really we want to show on our graph. So if we start off with labeling it, we're going to have number of kilometers on our x-axis, and on this axis here it's going to have our cost. Now that's measured in dollars, whereas this is measured in kilometers. So what this notation is telling us is we want our x-axis between 0 and 1,000. It's translating just a very mathematical way of saying it. 0 is less than x, which is less than 1,000, simply means x is between those two numbers. So what we can do is on our graph, I'm just going to put 1,000 up here. And down here we've got 0. What I want to do is have a look at what those values would actually look like, what the coordinate would be here and what the coordinate would be over here. And then all I would have to do is plot those two coordinates and join them with a straight line. Now what you can do is get your calculator to help you here, because you've got the rule, it's right there, 80 plus 0.22x. And then you could use your graph trace function to get these coordinates really, really quickly. So I'll show you what I mean. If we go to graph. Now, remember this part is our y equals, so I'm not going to write y equals or c equals. I'm going to go straight into writing the y-intercept and then 0.22x, which is what my rule was. I'll press enter. You'll see I can't see it, and that's because the y-intercept is all the way up at 80. So I'll just go to my window and go zoom fit, just so I can actually see the graph and I know that I've put it in. Next I'll go menu trace and just graph trace, and you'll see that my first coordinate here, which is my y-intercept, is 0, 80. So back on my first page, I'll just make a note that my first coordinate is 0, 80. I'm just not putting it on yet, just so I really want to know what this second coordinate is first, just so I can get a rough scale happening on this side. Now I want to know where is the graph, or what is the cost when the x value is 1,000. So all you have to do now is actually type in 1,000,000. You'll see it comes up with x equals 1,000. Press enter and it will take you to that coordinate. Now don't be afraid of that. It's converted 1,000 into scientific notation. It'll do that sometimes just because the calculator will only show you a certain number of digits. So that is 1,000 just there. And if you move back and forth, actually, you see that it changes it back anyway. And then 300 is the cost at that point. Another option would have been just to substitute into the rule 1,000 kilometers on 0 kilometers and then have a look at what the cost is. So I'm just going to make this point up here. This is my, try and line it up as best I can. That is my point 1,000 and then this one is 300. That means I can sort of break this into thirds. That'll be 100 and 200. And then roughly at 80, which is about, say there, I'll have my other coordinate. And then I can connect that with a straight line. I'll just have to do that. And then I'll mark those two coordinates onto the graph. Finally, I'll label the graph. So it was C equals 80 plus 0.22x. And I've got labels on my axes as well. So as you can see, we've just graphed it. We've shown the intercept, which was here, and we've shown the end point. This here is called the end point because it's where the axis on our x, the numbers on our x-axis had to end because that's where we were told to graph to. So it's where your graph ends, basically. Finally, for this one, if the final cost was 245, so that's C, what was the distance covered? So what is x? Now, once you've got your rule, that means we can substitute. We can substitute C or we can substitute x. In this case, we're substituting C because we're told that it's 245. And we're trying to work out what x is. So this is where we'd go to our calculator. We would use solve. I won't bother doing that. You can do that on your calculator, but what you should find is it comes out as 750. And then since it was asking for the distance, we put in the kilometers as well, since we knew that that's what the unit was for distance. So there's one with cost, like I said, very popular ones that come up. There is one more I wanted to show you because this last one is a little bit different to previous ones. Previous ones we were either given the graph or we were given enough information to get the equation quite easily. This one's not as obvious. This final one says that we've got a charge of $35 to steam clean a bedroom or $55 for 3 bedrooms. So since that's all we were told, we haven't been told anything about an initial cost. We have not been told anything about a price per bedroom. So you can't gather straight away what the equation would be for this particular scenario. You'll notice the first question as well actually asks us for the linear model. We have to think a little bit differently. So first of all, think about the variables. So we've got number of bedrooms and we've got the charge or the cost. Now you notice it talks about that here. It says express the charge, so I'm going to call that C, for steam cleaning a house containing n bedrooms. So we've got these two variables. So really what we want are some coordinates that are in this form. So the number of bedrooms and the cost for that steam cleaning. So if you have a look here in this information, we actually can get those two coordinates. For 1 bedroom, it was going to cost $35. So our line is going to pass through that point. For 3 bedrooms, it's going to cost $55. So the line also has to pass through this point. Now, using our little strategy that we had from a previous lesson, using 2 coordinates to generate a graph, we can do that really quickly using the CAS because we can go onto listen spreadsheets. I might just put it in as X and Y, but you can use N and C if you want to. We have this information, 1 for 35 and 3 bedrooms for 55. So data and statistics, and I'll put that on a graph. And then if we do our analyze regression and show linear, we can see our equation. So our equation must be C equals 25 plus 10n, since we had C and n. Okay, now if you have a look here, we're going to do a similar thing to a previous question. We're going to graph this linear model. We're going to graph this here, but this time we want a different scale. It's going to go from 0 to 5. So on this axis here, n, which was the number of bedrooms, we want to make it go up to 5. So 1, 2, 3, 4, 5. That will do. Okay, and I'll just put this on here. Charge. Okay, now we've got this rule. So again, you could use your calculator to help you. I'll just go back to this one and I'll just delete that graph. To get a new one, you can just press tab. It's going to let me put a new one in. Okay, so we had 25 plus 10n. Oops, I don't want an n actually, I want x. Common mistake. 25 actually. Just undo because it won't like me having another graph. So tab 25 plus 10 x. So you'll notice that I accidentally put n before and it didn't like it at all. So just make sure you do have x there. Menu, I'll just make sure I can see my graph by doing zoom fit. There it is. And then I want to know where that graph is. So I want to know where it is for the x value or the n value of 0. So I'll press 0 and press enter. And as expected, it's at 25 because that's my y-intercept. So I'll make a little note that it's going to go through 0, 25. And then I will need to know the endpoints. I need to know where it is, the end of the graph, because it's going to go up to 5. Where is it when n is 5? So I just press 5 into my my graph screen and press enter, and you'll see our second coordinate is 575. So once you've got the ends of the graph, then we can start to put it in. So if I go just call that 75, then I can just maybe go up in thirds again. So 25, 50. 25, 50, 75. And that works out well because our coordinate here at n is 0 was 25. All right, we want to connect that. You also want to label those coordinates. And you want to write your rule as well on the line. Okay. Now, with your last couple of questions, the call-out fee charged by the cleaner. In other words, how much is charged before any rooms are cleaned. Now, if you have a look here, we can just go to the N, which was our rooms. I just put that there. So when there are no rooms cleaned, 0 rooms, you'll come up and you can see that the charge there is $25. So if you consider our rule here, that initial value is starting point of the graph, which is our y-intercept, is 25. So when n equals 0, c equals 25. So when no rooms are cleaned, it costs this is the call out fee. And I'll just put in brackets, it's the y-intercept. In this case, the c-intercept, since we had c on that axis. How much does the cleaning company charge per room? See that word again, per, is our slope. And so if you have a look up here, our rule is 10n, so our slope is 10, meaning that every time you move across the graph, it's moving up by 10. So it goes, one room was 35, two rooms is 45, three rooms is 55. That matches the information that we had above. So the costs $10 per room. It says what part of the linear equation gives this information? It is the slope. Or gradient. All right, and I'll obviously finish there because we've done our 4 examples now. You can see that they, whilst they are obviously very different scenarios, there's lots and lots of similarities between them in terms of identifying those key features, the y-intercept and the gradient, using some substitution, using some solving, but also, importantly, being able to graph those effectively. So I'll stop there so you will be able to do some of this practice yourself, but obviously you do need to let me know if you are struggling with any of the stuff that I've covered in here, or if you are stuck on any of the questions that you are about to complete.